Any fuel?
Doesn't look like it.
Son of a mother piece of Honda K-swap. Welcome to VTEC Academy. We're all about to get schooled. So we have a little bit of a problem. Our computer did not turn on. And there's actually a series of things that happen when you turn the key on a K-swap. First of all, power goes to the ECU telling it you turned it on. That in turn tells the ECU to ground the main relay, or main relay 1. That in turn, it looks at the immobilizer and turns on the fuel pump relay. And then the fuel pump should pump for about 3 seconds while it kind of primes the engine, gets fuel pressure up so it starts quickly. None of that's really happening. Our ECU is not even turning on. So what I'm going to do is I'm going to show you how to troubleshoot for those very things. It's not uncommon for a K-swap, particularly if you did the wiring yourself, something to not be quite right. So we're going to step by step look at everything as it should happen and see where it's going wrong and repair it. So I'm going to pull this thing off the lift so we can open up the doors a little bit wider, get it in and out a little bit easier, and we're going to start checking voltages and seeing what's going on. So we're going to talk a little bit about how K-series ECUs work and how they interface with the older cars. So let's start off with the main relay. In a K-series, there's 2 separate relays. In the OBD 0, 1, and 2, there's actually one, they call it a main relay, but it's got 2 relays internally. And it has to do with some of the shared voltages and stuff like this. They decided to do it internally in the relay rather than out externally. These have the same shared voltages, or same, shared wires, but they do it a little bit differently. So anyway, let's talk about the sequence here. So when you first turn on your ignition, here at E9, you should get 12 volts, and that tells the ECU to turn on, which in turn will then ground this main relay. Now on the OBD 0, 1, and 2 cars, that relay is actually always grounded. So it's not something that happens afterwards. But in this particular car, it grounds it. And then once that happens, it also provides power to these 2 wires, A2 and A3. So this ground turns on the relay, and that in turn turns on power to these 2 wires. So once that happens, your ECU looks for the immobilizer signal, and then it grounds the fuel pump, or the second half of the main relay, through this immobilizer fuel pump ground right here at E1. So when we're doing a troubleshooting guide, what we do first is we turn the key on and we look to see if there's 12 volts here at E9. The E plug is actually in your sub-harness, so that's something that gets wired in. So is it actually getting a 12 volt signal? If it is, then we look to see if the first part of the relay is turned on and we are getting power at A2 and A3. If we're not, we look to see if there's continuity between the main relay ground and the black wire on your main relay in your OBD 0, 1, or 2 car. So if that is satisfied, then the ECU should be turning on and it should be grounding the fuel pump relay. If it does not, there are several problems it could be. Number one, you didn't load a program into your ECU telling it to ignore the immobilizer. That's pretty common. People will do a bunch of troubleshooting and then figure out that they forgot to click that or tick that box in the program and upload it to their computer. So make sure you've done that. If it is done, then that in turn should allow the immobilizer, allow the fuel pump to be grounded. Now, ours is not getting that far. In fact, it doesn't even look like our computer's turning on. So there's an issue with that. So I feel like if we troubleshoot these 2 things, we're going to figure out what's going on. So we're going to go real quick, look, see if we have 12 volts there, and then if it's turning on the first half of the relay, if we're getting 12 volts there. So let's do that first. What we are going to do is we're going to look for 12 volts at E9, And then if we get E9, we're going to look for it at E2 and 3, or A2 and 3, excuse me. I should probably have my manual over here so I can tell what the hell I'm doing. The voltmeter's set up for 12 volts. We got what I believe is a good ground. So we're going to start off connecting into E9. 1, 2, 4, 5, 6, 7, 8, 9. And we need to turn on power. All right, so we've got it turned on. And we have voltage. So, okay, so E1 is getting, or E9 rather, is getting 12 volts when it's turned on. So we'll look at A2 now. That's these yellow black wires over here. By the way, this is a T-pin. I'm using it as a back probe.
Not like T-Pain?
Not at all like T-Pain. Unless you jab yourself with it. And then that would be T-Pain. Yeah. All right, so if the first half of the main relay is turning on, I should be getting 12 volts here too, or voltage. Yeah, I have voltage there too. Okie doke. Well, main relay 1 is turning on, but it's not turning on the fuel pump. So what I'm going to do is I'm going to check continuity to see if our secondary, the immobilizer fuel pump relay control, is properly wired to the ECU. So that's where one of these wires from the ECU goes to. So let's look up and see what wires those are. So we're looking for a fuel pump relay trigger, and that here is A16. By the way, it's the same for 96 all the way to 2000. This is the 99-2000 wiring. It's the same regardless. So we want to make sure that our fuel pump, our immobilizer, is connected back to that wire, because that wire then connects to the second half of our relay. So we need to check continuity on that. So we know that wire is green-yellow. So we just need to make sure that our wire is that same color. Again, I built this harness, so the question is it correct? For checking this, we can unplug it. We don't have to have it plugged in. So 17, let's go, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Well, I'm happy to say there is a wire there. So chances are, and it is green-yellow. A16 over here, that's also green-yellow wire. So 1, 2, 3, 4, 5, 6, 7, 8 wires across the top. 9, 10, 11, 12, 13, 14, 15, 16. There's our green and yellow wire there. All right. All right. So it is in fact connected to the right place. So the ECU should be saying, hey, turn this on. So, but there's no lights on. So I'm going to guess we have a bad ground for the ECU. So we're going to check the grounds in the car. We should have continuity from these two black wires right here. 1, 2, 3, 4, and 5. Those are grounds. We should have continuity of those to ground. So let's check that out. All right. We're going to clamp onto our ground again. So you could have two bad grounds. We have ground. But just let me explain, you could have two bad grounds. You have the ground for the engine harness onto the engine, and then you have grounds from the engine to the chassis. Obviously we have continuity, so the ground is okay. So it leads me to believe that something else is wrong in the wiring, and through experience, that's typically there's another ground on something that shouldn't be grounded, and that's causing the ECU not to work. So what I need to do is I need to unplug everything from the engine harness to the engine, with the exception of the ground wires. Those are the only things that I can still have on, because that would allow the ECU still to ground properly, nothing else to be connected in the system, and hopefully our fuel pump will turn on. And if that's the case, we don't have a bad ECU, we've got something grounded that shouldn't be grounded. And if that's the case, we'll then kind of plug in sensors one by one until we find the one that causes the ECU to stop working. So here we go. Let's go in the engine bay, disconnect everything except our grounds. If I was using an RSX harness, I would just unplug every single sensor, and that would disconnect everything. But this, and I could do that with this Accord harness, but the Accord harness has something else as well. It has a connection here that interfaces between the engine harness and the computer. So I'm going to go ahead and disconnect both of those. And now what I've done is I've made this little ground harness right here. You can see it's connected here to the engine and has a couple terminals on it. So I've made this tool, and what I'm going to do is I'm going to plug into these two black wires, which are our grounds for the ECU. Those wires that come from the ECU come out here. So if I just connect to those, I now have our grounds. And everything else is disconnected. Kind of cool because I don't have to disconnect everything. From here, if my ECU works, I can plug in one of these plugs and see if it causes a problem. If it does, I know it's everything in this plug that might be a problem. If it turns out I plug in this plug and it causes the ECU to spaz out, then I know it's all the stuff that's in here, and I can tell what those are by looking at my wiring diagram. So that's connected. I'm going to now turn the ignition on again, and we'll see if the fuel pump and the ECU turn on. By the way, why don't you check to see if we get fuel? Look, we've got lights.
Oh,
Fuel?
we have fuel.
That's awesome. Well, that turned our computer on. So I have a wiring problem, and it makes me kind of happy it's not the conversion harness I made, because that's still connected. I suppose it still could be, but I don't think it is. So next step is I'm going to connect the side of the harness that didn't have the grounds, cycle it on. If it doesn't cycle on, then I know that there's a problem on that half of the harness. So, oh, by the way, had that not turned on the ECU, next thing I would have done is I would have looked for a different computer to put in, or I would have taken this computer and put it in a different car. Luckily, I have several cars, so I could have run it in a different computer or a different car. Or I would have taken the main relay and tried it in a different car and see if it worked. If it didn't, I would have taken the good relay out of the other car, put it in here, and tried it all over again. I tend not to jump to the conclusion of there being a bad relay, although many times that is actually the problem. I prefer
if it was the EF.
Pardon me?
If it was the EF.
Yeah. So I do like to I kind of go through the process and try to figure out what is actually going on, which is what we're doing today. So next, we're going to leave this site unplugged, although it's still got the grounds, and we're going to take the smaller of the two plugs and we're going to plug it in, and we're going to try switching it on again and see if that's where our problem is. Okay, it turned on.
And the fuel still looks pretty decent.
It's pretty clear?
Yeah, pretty fuely.
That's awesome. Yeah, I mean, it's just got the slight normal gasoline yellow tinge to it, so I feel like with two things. First of all, I'm going to take this and pour it in the ridge line because it might be a little bit old. But I think if we just dilute it with fresh fuel, we'll be fine. And I did get premium for this. Or did I? No, I didn't. It's an Accord motor. I didn't care. So anyway, we'll put fresh fuel in. And we can actually hook up our fuel line and check for leaks after we're done here troubleshooting this part of it. Well, heck. All right, so, I mean, the first thing I'm going to do actually is I'm going to compare wire for wire all the colors and see if something doesn't stand out. If it does, I'm going to try and repair that first. If it doesn't, then I'm going to find out all the sensors that are associated with this plug. I'm going to unplug them all from the engine, and then I'll plug them in one by one until I have the problem again. So, yay, electrical. Just checking the outside colors, they're all correct. So, I'm going to be lazy here for a minute and not check the inside. I'm going to assume they're correct as well. Let's just connect this harness and not the other one and see if we get the same fuel pump on.
Do you need to ground it with those?
No, they're grounded now.
Oh, the...
Yeah, these two black wires that were here ahead of time, they should be grounded. If not, I'll check continuity on them, but for sure they got to be grounded.
Okay.
I doubt. There's a ground right there. So I got to believe they're grounded. Oh, I know they're grounded because we checked them with continuity earlier. They're grounded. All right, didn't turn on. It did not turn on. So now what I got to do is I get to grab the manual, the ETM for the Accord. I need to look at everything that comes through that particular connector. I'm going to disconnect them all from the engine, and then one by one I will plug them back in and see which one is the bane of our existence. So paperwork. So I printed out the C201 plug, which is one plug that makes it not work. And what I need to do now is I need to figure out where each one of these goes, what sensor it goes to. If I can figure it out, then I should be able to unplug each one of them and then plug them in individually and see which works. No, I'll tell you what would be interesting. I suppose I could unplug them individually and see when it starts working. Rather than plugging them in individually. Well, one way or another.
Unplug them until it works?
Till it turns on, because then it'll just pump fuel.
Yeah.
So I'll do it like that. Yeah, do that.
Look at that. Building a better mousetrap.
Yep.
Oh, that's not plugged
So I made a list. Alternator, CMP, crank position, cam position, coils, VTEC pressure switch. I have no idea what's on here, but probably just like an O2 sensor. So anyway. Yeah, let's turn it on. See if it turns on.
Let's see.
All right, it didn't turn on.
So it didn't turn on, so...
It didn't turn on, so...
It's none of those?
As far as I can tell, it's none of those. Cam A and Cam B, yes. Coils, yes. VTEC pressure switch, yes. CSS, yes. Eye control valve, yes. NOx sensor, yes. TPS, yes. Engine coolant temp, yes. Intake air temp, yes. Throttle position, yes. CSS, yes. Oil pressure, yes. Oil pressure. If it still doesn't turn on, that'll be weird.
If it still doesn't turn on, that would suck.
Yeah. Huh. It is still not turning on.
What does that mean? There's something from that plug that's still
I'm not sure.
grounding?
Well, so let's unplug this and replug in our two grounds. The grounds are plugged back in again. Let's see if it turns on.
Yep, there it goes.
It's so weird. Why? Why doesn't it work? That's crazy.
What does that mean for the harness?
I don't know. Like right now, we can turn it on and off and it pumps fuel. And then if we ground those two wires and we turn it on, it pumps and works fine. And then when we connect it through the ECU, suddenly it decides not to work. So.
And it doesn't matter the ECU, so it's got to be something in the harness. All right, so which ECU is this?
This is an 0506 RSX that we originally had set aside for budget EK. So I think we had it in Carter's car at one point. So it should be set up for just a K24. So it should run.
Because none of this other stuff is making sense.
No, it's not making any sense.
And you've done this a few times.
I've done this once or twice.
Oh, she liked the joke.
Somebody's having fun. It's not me. It solved it.
So it's like the VTC's grounding, or
The VTC's grounding.
or it's not getting sufficient ground?
Turn the VTC, plug the VTC back in, please.
Yep.
Had an interesting problem. We disconnected everything and it wouldn't turn on. So I reconnected just the grounds. Of course, it turned on. Then I disconnected the grounds, turned on, and the computer turned on. So it's getting a ground somewhere not where it should. Because when we add the ground through the wire harness, which actually winds up connecting to a bunch of different sensors, suddenly it stops working. So we decided to disconnect every plug. I disconnected the EGR, which we're not using anyway, and we disconnected the VTC. And the VTC was the one that solved it. So something's going on with the VTC. Now, VTCs are different on Accords as opposed to our earlier RSXs. The ground is actually in the harness. So either the VTC is bad and causing a direct ground, or perhaps our pins are bent on the VTC. So we're going to try changing the VTC and seeing if that repairs it. But at the same time, I think we'll do some continuity check on that and make sure both sides of it don't have continuity, because it's the VTC. Not really sure what it's doing, but it's the VTC. Another possibility is I modified the harness. So one of the things I do sometimes, one of the things I was doing with some of these harnesses was I was actually modifying them to work with the Hondata ECU. And that meant that I had to add a ground that went all the way back to the C201 plug. Now, if that's the case, it might be connected to something. We'll just have to check continuity and see if it is. But it should just be grounded straight to the engine through this connection right here. So let us see. Let's check our continuity. The black wire. It has continuity. The other one does not, like it shouldn't. So I would have added a black wire in there if I wanted to run it all the way back as a ground. Not turning on.
Nothing.
Huh?
Said nothing.
Nothing.
Isn't this more fun than doing burnouts down the street right now?
So much more.
Yep.
We still have a problem. Because we really couldn't figure out what the heck is up with this harness, I decided to go ahead and start over again. So went to the salvage yard, got an element harness. This is what we had before running this computer in a different car, same harness, and this requires less modification. So it's got a few modifications. It's been converted from auto to manual. I still have some ends to put on it, but it's good enough to get in the car and test everything out with our original Hasport sub-harness, not the one I built. It's making me wonder if I didn't take this built not bought thing a little too far, but you know, we'll see. Anyway, it's modified from auto to manual. It has everything it needs to run the car, so we're gonna go ahead and put it on and see if this thing won't fire up and make me smile rather than grimace.
And it's not a budget buster.
And oh yeah, what did I pay for this thing? $19.99. Yeah, the guy hooks us up. Pull this one off, put this one on, give it another go. We have the new harness on, and we have the different adapter harness. So we're going to check now to see if our fuel pump turns on. I see lights.
I see fuel pumping.
Right on. We're just going to try and fire it up real quick. We've got fuel pressure. Aaron checked for leaks. We have no leaks. We have about 50 pounds of fuel pressure. By the way, EK Series supposed to be between 47 and 53. We're in the sweet spot. Our new harness is on. The computer's turning on. I did have to make one change. This was an automatic originally, so in order to make the starter work, I made a little jumper. So this plug plugs into the transmission range switch, which is on the shifter. And these two thick wires right here are for the starter. So what happens is normally when it's in park or neutral, these are joined. They're not at this time. Now, if we want to be set up with a clutch that works properly, I'm gonna need to wire a relay in here. And then that way when you depress the clutch, if it has the clutch switch on it, it allows for the connection, and if you don't, you don't. And that way you don't accidentally start your car with it in gear and your foot off the clutch and drive into a wall.
Or your garage.
Or your garage, yeah.
Or your friend.
Yeah, anyway. We are going to kick it over and see if it fires. I didn't really test the injector, so your guess is as good as mine.
Maybe it'll take a little bit for it to...
Yeah, might take a bit.
Oh, I don't think there's spark plugs.
I don't think either. That sounds like it's pumping air in and out.
That was air coming out of the holes.
Okay. That's interesting. It was whistling past the little rubber stoppers on the thing.
They all went. Foop, foop, foop.
Okay, so what I'm going to do is actually pull them all out real quick, and it should turn over a little quicker, and we try to get a little oil pressure in this thing. So normally I don't care about that stuff if the engine's run fairly recently, but honestly, I don't know when this engine ran last. It's likely that we stole the plugs because the coils are back in, which usually means I didn't want anything to get in there, like rodents, water, things like that. So small insects. Anyway, so that was pretty funny. Musical. I wonder if we could tune it and play something. All the the connections that need to be connected. Grounds, the two grounds. All right, well, let's see what happens. It wants to start.
Smoke ourselves out, dude. Look behind you.
Maybe the engine wasn't so good.
Hey, it works though.
Yeah, it did. It fired up.
Success.
All right. Well, we got fired up, so we need to hook up a bunch more stuff, and we need to air this place out.
Yeah.
So, let's see what we did on our budget for our budget EK. It's going to be kind of interesting. Oh, by the way, we're going to have a lot more videos like this, so please think about liking and subscribing, and also hit the bell so you get notifications when new videos come out.
Do it now.
Do it. All right, so let's look at what our budget is. Our budget for this car was $4,500, and we chose that amount because that's how much it costs to buy a B18C engine swap, and that would be a complete swap: engine, axles, transmission, pretty much most everything you would need. $4,500. So a K series is faster. Even the Accord motor, turns out, in our budget EG, was faster than a B18C Civic. So can we beat this amount? Can we be less than $4,500? A couple of years ago, in fact, 2016, when we did budget EG, the total amount we spent was $3,285. Adjusted for inflation, that's actually $4,426, just under our $4,500 budget. So this is the list of everything you use. So let's talk about that a little bit. First off, probably a big factor is what you get your engine for. Now, we found in the salvage yard a complete Accord engine of the correct year, with transmission, with alternator, with wiring harness, charge harness, all that sort of stuff, clutch slave cylinder, and even the ECU, and we were able to purchase that for $600. Now, you may not be able to find a deal like this, but we could have had it for less, as a matter of fact, because this wasn't even a discount day. So about $400 for the whole engine, about another $200 for the transmission, and that's what it cost us. Now, there were some core charges, but I didn't include those in because we figure had this car come with an engine, we just would have gave them that stuff, or sold it off if it was good running stuff, and actually been able to recoup most of our money. So anyway, this is what we got. We did a little inspection of the engine at the salvage yard. The car was hit, and that usually gives us a good clue it was running when it was hit. Also took a peek in the oil, under the oil cap, and it looked pretty good, so we chose this engine. So anyways, all these things came with that. So next up was the CRV block bracket. 15 bucks, you can get those off of 2002 to 2005 CRV. You can also get them off the Element, the same bracket. Cord shifter and cables. We were able to get, because this was a manual car, we were able to get the shifter and cables. We paid $50 for that. Next up was the Accord air fuel sensor. I had to shop around to a few salvage yards that actually pull those parts for you. I found one, a bunch of them actually, for between $30 and $35. We bought one for $35. We didn't get the secondary O2 sensor. We may do that if we decide to try to get this thing through emissions a little later on. New, those sensors are about $85, actually much less expensive than the ones for like the RSX and stuff. So $35 is what we paid. We also needed the intake air sensor. That was $9. Our particular engine did not have mass airflow, so we didn't need to get that. Next up, serpentine belt. We were not running AC, so it required a custom serpentine belt. This is the part number, and it was $23 online. Okay, so EK swap conversion harness. We actually made our own, but in the end, that didn't work out. So kind of a generic price for EK K-swap conversion harnesses is about 200 bucks. So they range from a little less than that to a little more than that, and they do have to be converted to be used with the Accord ECU. More on that in another video. Actually, we've already done a video on that. So I'll put a link down below to the video we did on how to convert a normal Honda style one to use with a K-tuner, which is the ECU we used. All right, next up was the K-tuner reflash. Now, K-tuner sells their according to you two-way. They sell one way with simply a reflash. It's about 300 bucks. That's what we went with. And the other way with actually a daughter board installed, which then allows it to be tunable. That winds up being about $300 more. You can choose which way you want to go. We went with the reflash. Okay, next up was Hasport's EKK one mount kit. Now the EKK one mount kit is the one that allows you to use the stock EK subframe, which again, we're trying not to buy an EG1. We wanted to keep the budget as low as possible, so we opted for that particular kit. Now let's talk about that briefly. That means that on a K24, it's actually going to touch the hood slightly, so you're going to have to do a little bit of massaging of the structure, the skeleton under the hood in order for it not to rub. But that's the mount kit we went with. Next up is where we're right here. Hasport K-swap axles for the Accord intermediate shaft. Now, when we bought our Accord engine, it came with the intermediate shaft, and that's like 2.5 inches longer than the SI intermediate shaft. So we needed a custom axle for that particular side, which is the right axle. So Hasport actually makes that axle. So if you buy Hasport axles for that intermediate shaft, you wind up with the short axle that works well, and that was $567. Okay, next up is the K-Tune swap header. We opted for that because we found a really good deal on it. We were able to purchase that online, locally, $308. And actually, we didn't actually purchase it. We had one left over from another swap, but we found one online for 308 bucks, so that's why we have that price. You can also use a DC Sports one, and there are other companies that make them as well. But this was the name brand, inexpensive one we found, so 308 bucks. Next up with the fuel pressure regulator. We always want to go with something that isn't going to be one of those $60 ones you buy on eBay or something like that. Now, Evil Energy, we've been using their products for quite a while. My brother uses them for some of the Corvette stuff he does, so it's pretty good stuff, so we opted to use that. It was 76 bucks, pretty good price. Now, there was a bunch of miscellaneous fuel fittings and fuel hoses with that, because what we opted to do was actually make our own fuel lines. You can buy the braided stuff for, you know, that's pre-made and certain lengths, and that usually winds up being about 250 bucks. We're trying to save money there. So for about $45 in parts, using the correct type of hose, which that's this part number right here, Gates 30 R14T2, that's the stuff that's for the high pressure fuel system we have on this car. We were able to make that all for about 45 bucks. Okay, upper and lower radiator hoses. Now, there is no hose that fits this that you can buy. We've got the stock radiator, we just moved it over to the side. So what we wind up doing is going down to the parts store, finding a couple of hoses that had all the bends in the correct directions that we needed them, and then we purchased those. And it wound up costing us about 44 bucks. I'm sorry I don't have part numbers on that, but we wound up actually cutting them up and using them like that. As a matter of fact, one of the things we did was used an 1.25 inch joiner with clamps. That was $16 on Amazon, and that allowed us to cut up 2 curves so that we were able to get it to clear underneath our cold air intake and work well. If your cold air intake, if you're using a different engine, your cold air intake may not be in the way, but ours was, so that's what we wound up doing. Also, we used the Hasport radiator hose adapter, and we used that because we wanted to put a water temp sensor and a radiator fan switch in the hose adapter, and that allowed us to operate the radiator fan when everything was hot. So that was it. Now, the 2 sensors that go in that, we didn't need to purchase those. If you have a car with an added engine, you will, but basically the radiator fan switch and the water temp sensor come off the stock engine. So we just pull those off the original engine, plug those into the hose adapter, and then the adapter harness had wiring for that. All right, next up, there are a few other things that we needed. There was a bunch of hose clamps we needed. Also, there was those silicone sleeves that I use in order to scale the inch-sized or 1.1/8 size radiator up to 1.25 so our radiator hoses fit properly. I'll put a link to that silicone in the show notes, but basically you only need a few inches of it, and you should be able to find it somewhere for a good price. We actually bought, I think, a 5-foot section because we do so many of these swaps. Next up were the heater hoses. For heater hoses, about $28, and those we bought online as well. These are the part numbers. One of the heater hoses has a 90-degree turn in it, and that we find works real well. We don't have to redirect the bypass valve for the heater core. We can just hook this 90-degree piece on it and then cut it to length so that it fits properly. That 90-degree actually helps keep it out of the way of the header so it's not passing by the header too closely. The other hose was an AC Delco hose, and the AC Delco hose has two different diameters. On one end it's 3/4 inch, and on the other end it's 5/8 inch, and for whatever reason, Honda has upsized one of the heater hose fittings, so you'll need that dual size hose. And it's basically a straight piece, so you connect it on, curve it to where you want it to go, and then cut it short, and it works just fine. Next up was miscellaneous wiring and connectors. We did some custom wiring on this. We actually modified the Accord charge harness in order to work in our car. So we wound up purchasing some battery terminals and some other miscellaneous plugs and things like that. Again, there'll be notes to those sources in the, links to those sources in the show notes. That's one of the big differences, by the way, between what we do and what you may be capable of doing. Unfortunately, we have all the tools we need for doing this kind of stuff, so that may kind of impede you from doing this as cheaply as we do it. All right, so next up, another good example of the same thing, the Napa brake line. For our clutch line, a lot of people sell a very long braided line for the clutch master to clutch slave, and it's actually kind of expensive. What we chose to do is use the stock lines, which came on our engine, and the stock soft line, and then we made a short little connector that went from our clutch master to the frame rail to hook it up. That piece cost us $16, actually $15 and pennies. The other tool we needed for doing the brake line was actually a flare tool. So normally when you buy the import or metric brake line, it comes with a bubble flare. We needed a dual flare, and basically, or a double flare. Basically that collapses down the bubble so that it's kind of a double wall of what looks like a normal single flare. So that tool was needed as well. Next up was the radiator cooling fan. Obviously the stock one won't fit because there's really not enough room once we move the radiator over. So we bought an aftermarket one for 29 bucks online, and we're gonna attach it using the hardware that comes with it, which basically goes through the fins and connects the fan right to the back of the radiator. Next up, if you recall, we had a lot of problem with our engine harness. Now our engine harness came with this. We tried to modify it. I still haven't finished troubleshooting it to figure out what I did wrong, because obviously I did something wrong. What we wound up doing is going and buying an Element engine harness. And this is actually an easier harness to work with to begin with, because if you have that harness, it actually already has a C101 plug. You just have to repin a few things, and then that is a lot easier to work with your adapter harness. So we were able to find an Element engine harness from an automatic. We kind of cut off all the automatic ones, added a few wires for our basically for our VSS, or our counter test speed sensor, because it didn't reach, so we had to lengthen a few wires. But that Element engine harness only charges 19 bucks. Now, that's a really good deal. I mean, I would expect to pay more than that normally, but for whatever reason, they hooked us up and we got it for 19 bucks. Last is the intake air filter. Now, there's not one specifically that works for this. If you look at all the Accord intake air filters and the TSX intake filters, which go with that particular angle on this throttle body, they all kind of go over to the side of the car, not back like a normal short ram. We were able to find something online that was kind of a more basic one, 120 bucks. We got it on eBay, made a few modifications to it, and that's what we're using as our air filter. So all in all, these are the parts, these are the prices, and our grand total was $3,288. We did it. We were way under the $4,500 we were thinking about. And here's the crazy part. This engine, if I would have found a TSX in the salvage yard with a manual transmission, it would have been the same price. I would have had a 200 horsepower motor rather than a 160 horsepower motor for the same price. So crazy. We do, by the way, look for them, and I've probably picked up, I don't know, 6 or 7 of them over the years. We did not find one for this particular swap, and I got kind of tired of waiting for it. But those deals are out there. You just got to hunt them down. I went recently on Pull and Save website, and there were a few TSXs that had come in fairly recently, and I'm betting the engines were there. We could have had more horsepower, a faster car, probably for about the same amount of money. Anyway, we're going to be wrapping this car up, trying to get it out on the road. We're going to take it for a rip. We're going to see how fast it is. We're going to compare it against a B18C powered car. So please check out that video, and you can see how fast our Cord K-Swap is compared to a B18C. Anyways, guys, thanks for clicking on us, and we'll catch you next time.